All right, we're going to be looking at level-to-level projectiles and the equations needed to solve those things. Now, first of all, as a reminder, a level-level projectile is one in which it is basically thrown into the air and thrown sideways at the same time. It is basically given both a vertical initial velocity and a horizontal initial velocity. As a result, the projectile will fly in a trajectory that is parabolic. I shouldn't say fly, it's more like it falls in a trajectory that is parabolic, because this is actually yet another example of free fall, which means there's only one force acting on it, and that's the force of gravity, which means at any given time, it only has a downward acceleration. I repeat, any given time, it only has a downward acceleration. Now, as a result, the vertical velocity will decrease. And in fact, at the very top of the path, the reason it is the top of the path is it has no vertical velocity anymore. It's come to stopping point for the vertical velocity. But because it's in free fall, there is no horizontal accelerations because there are no horizontal forces. As a result, it's not stopping in the x direction. It still has the same initial velocity in the horizontal direction. Now, how to actually find those velocities if you're given just the magnitude of the initial velocity and the angle or the direction of that which that magnitude is applied, well, that comes down to something called velocity vector resolution, and that's what's next. Velocity vector resolution. Now, basically, it's just trig. So let's see if I can move this over so you can see the triangle easier. And what we're looking at here in this case is you have a hypotenuse, which is V naught. It's how fast it's going. And the angle that's associated with that hypotenuse. And that angle is measured from the horizontal in this particular case. And as a result of that, if you want to find the opposite side, or the V naught y, you have to use the sine function. Hypotenuse times the sine of theta is the opposite side, or V naught y equals V naught sine theta. Now, the adjacent side is the one next to the angle, so therefore it's V naught cosine theta to find the V naught x, or the adjacent side. So that's how you resolve a vector. You just basically plug the hypotenuse in and multiply it by either cosine of theta if you want the x side, or sine theta if you want the y side. Next, the equations and the list. It turns out we're looking at two different motions happening at the same time. So when you go about trying to make a list of information that you know about the problem, you want to break it down into a horizontal and vertical list, at least. You could put a center column called the common column. Now, here's why they're called the common column. The theta is not associated with x or y. The V naught is not either. They're both kind of connected together because this is the magnitude and that's the direction of the initial velocity. So you have to break those things or resolve those down to find out how much is in the x and how much is in the y. Now, the time itself is common because it's actually the thing that both parts share. So if you're really kind of stuck on how to solve the vertical part because you can't find the time, then look to solving something in the horizontal to find the time. If you don't have enough information to find the range or the velocity in the x direction because you're missing the time, then that means you're going to use the vertical information to find the time. Now, the equations listed on the screen are all the equations associated with the horizontal side and the vertical side. And as a reminder, the horizontal side has no acceleration, so, well, there's really only one equation in different forms. Now, on the vertical side, all the kinematic equations are available because it does have an acceleration, a negative 9.8 or negative 10. Now, I'm showing it as a negative g, and in the equations, I'm putting negative g times t for how to find the velocity if you know the initial velocity, or negative 1/2 gt squared. So don't make the mistake if you use this equation putting in another negative. It's already in there. So those are the equations associated with the horizontal and vertical. And when you solve these, you really need to make a list to help make sure you keep things straight. Make a horizontal and vertical at least. And if you want to make a center column, you can call that the common column. And that'll help you keep organized when you're trying to figure out what you need to do to solve the next part. Now, that's kind of the equations. That's how you do vector resolutions. And there'll be a coming video that talks about how to use the symmetry of a level-level projectile launch to solve it.